Hello everyone. So we are here to discuss the paper of JEE Advanced 2026 conducted on 17th May. I am going to discuss paper 1 with you guys. So I'll try my level best to give you proper guidance about how to solve this question. It is not about just the solution of the question. It is more about learning the concepts involved, thinking about the ambiguity which is there and how to find the best answer. So let's start, and we'll start with question number 1. It is already there on the screen. I'll read it for you. So suppose we have a large disk of radius r. So this is a large disk of radius r, and there are two smaller disks, each of radius r by 50, lying on its circumference as shown in the figure. The smaller disks are initially in contact with each other and with an angular separation delta theta between their centers. So as you can see, their centers are separated by an angle delta theta. In fact, the linear distance between their centers would be roughly 2r. They are made to roll without slipping in opposite direction with constant angular velocity omega into omega. As you can see in the diagram, this one is turned counterclockwise, so it starts going in this direction. This one is turned clockwise, so it starts going in this direction. So they are made to roll without slipping. Now this is keyword is important, roll without slipping in opposite direction with constant angular velocity omega and 2 omega, while the large disk is held stationary. We have to find the time at which the smaller disk are again in contact. So this wheel moves certain point here, and this wheel also moves to some certain point here, and they again come in contact. We want to find out the time after which they come in contact with each other. So let's break the question down, understand what is the idea. So two key ideas. One of them is the rolling without slipping. So rolling without slipping means that the speed of the center of the disk can be related to its angular velocity by the formula v is equal to r omega. So for the disk which is turning counterclockwise, its speed will be r omega, and for the other disk, let's say vc prime, and it will be going in this direction with the velocity 2r times omega. So what happens is, now look at this situation carefully. The center of the disks, they start moving in circular paths and they meet after some time. So now this question becomes something like two particles are moving in a circle. One of them is going counterclockwise, other one is going clockwise, and when they do meet each other. So we have to think of delta t, and one of the particle traverses theta 1 angle, the other particle traverses theta 2 angle. If they were actually particles, then I should have taken theta 1 plus theta 2 is equal to 2 pi. But there is a catch over here. Since these are finite size particle, I'm not going to take theta 1 plus theta 2 is equal to 2 pi. I should be thinking about that again this angle will be delta theta. So this angle turned by one of them and the angle turned by the other one, they should add up to 2 pi minus 4 theta. So theta 1 plus theta 2 should be equal to 2 pi minus 4 times delta theta. So the time would be dependent on this, and as you can see the option is either A or C. Well, I could guess after this point what should be the answer, because I can see that this one is going with speed r omega, the other one is going with 2r omega, and they are going in opposite directions. So the relative must be 3r omega, and the relative angular velocity therefore can be written as 3 omega, and the time will be has to be divided by 3 omega. So answer must be option C. So this question is interesting, and JEE has asked this kind of question earlier also. There was a question, there was a desk fixed and a coin rolled over it, and it was asked that while the coin completes one revolution, how many revolutions it completes about its own axis. So a repeat kind of a concept, and it is pretty common for JEE. They will ask from the basics, but then they will manipulate it in a different way. So this is a very nice question, just testing the basic understanding of circular motion and pure rolling. With this, let's move on to the next question. So we are here at question number 2. This is also a nice question, and this question has a lot to understand. Multiple things are there. Let's understand it deeply. So we are given a circuit that consists of a capacitor of capacitance C. We have a capacitor of capacitance C and a coil with n turns per unit length, cross sectional area S and length D. So you can see this coil is there whose length is D and cross sectional area is S. Now there is another coil of length D by 2, cross sectional area S by 2 and 2n number of turns per unit length completely inside the larger coil. So within it there is another coil. So this looks like a mutual induction kind of thing, two coaxial solenoids. Okay, the ends of this smaller coil are connected with each other by an insulating conducting wire. The self inductance of the larger coil is L. We have to neglect edge effect and all the ohmic resistance and find the resonant frequency. Now we have to neglect the edge effect and ohmic resistance. That means we have to think of like long solenoids, field can be taken as uniform. We have to find the resonant frequency, and the ends of this smaller coil are connected with each other by an insulated conducting wire. These are the key words you need to understand. And if I had simply an inductor connected with the capacitor, the frequency, resonant frequency omega is 1 by 2 pi root LC. Sorry, not 1 by 2 pi, it is 1 by root LC. And now there is a catch in it. We don't have a simple inductor. Within that inductor, another coil has been placed. If that coil were not short circuited, then there will be no current in that coil. In that case, that will not affect the inductance, and in that case, the answer would have been 1 by root LC. I expected one of the options to be that. Anyways, you are saved because there is no such option. So we have to think more. Now this coil is short circuited and we want to find out basically the effective inductance. The answer should be of the form 1 by square root of L effective times C. So we are interested in calculating the effective inductance of this. Okay, to find the effective inductance, I should think about current. So let's suppose I1 is the current in the outer inductor and I2 is the current in the inner inductor, inner coil you can say. Now if I think of L effective, so I should be thinking about the total flux through the outer inductor. I should be able to write it as L times d I1 by dt. Sorry, I should be able to write phi as L times I 1. So this is what I am interested in. But over here, when a current I1 flows in it, I2 will also flow and the flux has to be written differently. Notice this carefully. If I am interested in calculating the flux through the outer one, it will have current due to its own current and it will also have a current due to mutual inductance. It will also have a flux due to mutual inductance. So the flux due to own current or self current will be L1 times I1, and due to the current, let us say I2 in the inner coil, there must be a flux which is M times I2. That is the idea. One of the coil has a current I, then in the neighborhood if I place another coil, the flux in this coil will be dependent on this current, and the proportionality constant is the coefficient of mutual inductance M. So phi 1 will be L1 times I1 plus M times I2. Similarly, I may write phi 2, and phi 2 will be the self-inductance of the coil 2 times its own current, plus it will have a flux due to the current in the outer solenoid that must be related by M, and it must be M times I1. M is common. It is called reciprocity theorem, that you pass current through this, find flux through this, or you pass the same current through this, find the flux through this. The proportionality constant remains the same. That is the coefficient of mutual inductance. So I have this relationship. Now I would be needing to calculate L1, L2 and M, and also I need to eliminate I2 because I am interested in this. So let us first eliminate I2, then we'll calculate. It is given in the question that the second coil is short circuited and there is no resistance. In a general circuit, we should have net EMF is equal to current times resistance. So for the second coil, Kirchhoff's law equation should become net EMF is equal to I2 times R. Since R is 0, so the net EMF must be 0, and therefore the flux in it should always remain 0 because it was initially 0, so it should always remain 0. So I should get L2 I2 plus M times I1 is equal to 0. From here I can calculate the value of I2 as minus M I1 by L2, and I will plug this into this so that I get phi 1. Phi 1 will be L1 times I1 minus M squared by L2 times I1. So we have actually derived a formula for effective inductance of this case, L1 minus M square by L2 times I1. So the effective inductance is L1 minus M square by L2. Right. So this is what we are going to use. Now I need to find L1 and L2. Let us find L1 and L2. We are given L, I know. The formula for L is mu naught N squared A L for a solenoid. N is number of turns per unit length. A is the cross-sectional area and small as the length. So L1, let us talk about L1 for the outer one. It is mu naught. The number of turns is capital N. It is given in the question, N square per unit length. Area is S and length is D. And this value is given to be L to us. Now let's talk about L2. L2 will be mu naught times the number of turns, which is 2N square, times the cross-sectional area times the length. This also comes out to be L. They are trying to keep life easy for you. And now M. M will be calculated by mu naught number of turns per unit length N1, number of turns per unit length N2 into A into L, which A and L are the smaller out of the two values, both of them. So A is S by 2, L is D by 2, and N1 is N, N2 is 2N. When I plug in this value, I get M as L by 2. So if I plug in all these values, I can find L effective. So L effective will come out to be L minus L by 2 whole square by L, that is L minus L by 4, 3L by 4. So I have to plug in the value 3L by 4 in this formula, L effective. If I put 3L by 4, I should get C as my answer. So the correct answer to this question is option C. So you see, one question involving multiple concepts, calculating mutual inductance, then calculating the effective inductance, and knowing the formula for the resonance frequency of LC oscillatory circuit. That is the beauty of JEE. Okay, let's move on to the next question. This also reminds me of some old questions asked in JEE. They are very fond of asking this question, when will a body leave contact? Let's read the question. We have a solid cylinder of radius r that rolls without slipping with the center of mass speed root gr by 3 on a horizontal surface, and there is a vertical edge. So the horizontal surface terminates somewhere. G is the acceleration due to gravity. At the moment when the cylinder loses contact with the surface due to rotation around the corner, speed of the center of mass. Now this is important, due to rotation around the corner. Don't treat it like a block sliding on a surface, that if I just had a block sliding on a surface, I have a surface like this and I place a block like this and I throw it with some velocity, this flies off. This is not a situation like this. It is clearly saying due to rotation around the corner. So what happens is, this object rolls, it reaches the corner, and then it starts rotating about this corner. Because it is rolling without slipping, this point is instantaneously at rest. So the velocity of this point is 0, and from this point onward, this begins to move in a circular path, and somewhere in the circular path the normal contact force becomes 0 and it leaves contact. That is what we are required to solve. So I'm going to move on to the next page to solve this question. So initially the center is here, and this has a velocity v naught, and this is also having an angular velocity omega, which will be v naught by r. It is pure rolling. And then this center begins to move in a circle. I'm not showing the object, I'm just showing the circular path followed by the center. So the center moves in a circular path like this. So effectively it is moving in a circle of radius r. And when it is at this place, and if it is moving in a circle about this point P, it must have an acceleration v square by r. The forces that would be acting, let's think about the forces. So forces would be mg vertically downward and a normal pressing force like this, and there will be a static force of friction like this, and the acceleration is in this direction, v square by r. And let's say this has turned from vertical by angle theta. So this angle is theta, this is theta. So I can resolve the forces along the normal and the frictional direction, and I may write mg cos theta minus n as mv squared by r. When n becomes 0, we get v square is equal to gr cos theta. So the speed of the center of the disk becomes gr cos theta. Now how to find the speed at this moment? And related with the initial speed, I need to use energy conservation. Initial translational kinetic energy half mv naught square. Initial rotational kinetic energy half into the moment of inertia. Solid cylinder, so it is like a disk. So moment of inertia will be 1/2 mr square into the angular velocity v naught by r whole square, plus initial gravitational potential energy. Let me choose this as a reference. Then initial gravitational potential energy is mgr, and I'm going to equate this to final. Final will be 1/2 mv square plus 1 by 4 mv square. I have used this idea. This value will become 1 by 4 mv naught square. Plus now the height becomes r cos theta. So mgr cos theta. So this is 3 by 4 mv naught square plus mgr is equal to 3 by 4 mv square plus mgr cos theta. And we are interested in calculating the speed. So I have this expression, and I can replace gr cos theta with v square. M will cancel out. So 3 by 4 mv square plus V naught square is already known to me. Yes, V naught square is also known to me, GR by 3. So let's plug in the value. So this is 3 by 4 times M times V naught square is GR by 3 plus MGR is equal to 3 by 4 MV square plus M times GR cos theta is V square. This is 7 by 4 MV square on the right hand side, and this is 5 by 4 mgr on the left hand side. So we get V as square root of 5gr by 7. That is the answer. Let's check it out whether I did it correct or not. Yes, 5gr by 7 is the answer, and that is the correct answer for this question. Okay. All right, so let's move on to the next question. Now this question has an ambiguity. I might not be able to resolve that ambiguity because there are different definitions of power given. We need to very clearly tell how to define power, then we will be able to solve this in a better way. Anyways, I'll tell you the idea. We have a double convex lens that is made up of glass of refractive index 1.5 and radius of curvature of the curved surface 20 centimeter each. So he's talking about a biconvex lens. So we have a biconvex lens and the radius of curvature is 20. So R1 I will take plus 20 and R2 I will take as minus 20. And this is made up of a material of refractive index 1.5 and the surrounding medium is a liquid whose refractive index is given as NL. Okay. The correct plot showing the variation of power in diopter as a function of NL is. So diopter is meter inverse. So I need to convert centimeter into meter carefully, and I have to think about the power. Now power is defined in different ways. Power is in the standard text defined as 1 by F, but actually there is another term which is called reduced power or vergence, and this reduced power or vergence is the refractive index of the medium divided by F. I'll make you understand both of them, not derive it. The second one can be derived easily. So for a spherical refracting surface having a refractive index mu1 on one side, mu2 on the other side, and a radius of curvature r, the vergence or the reduced power is actually mu2 minus mu1 by r. So if I have a lens like this, then I will write power as this is mu naught, this is mu, this is again mu naught. So I should write mu minus mu naught by R1 plus mu naught minus mu by R2. If I plug in those values, I should get a different answer. And in the standard text, power has been defined as 1 by F. Let's solve it one by one. First we'll solve it for this case. So if I solve it for this case, it will be 1.5 minus the refractive index of the liquid divided by 20 centimeter, that is 20 by 100, which is 5 in the denominator. No, not 5 in the denominator, my bad. So it is 1.5 minus NL divided by 20 centimeter. So I multiply this with 100. And then the second one is, this is R1, right? And then second one is mu naught, this is NL minus mu1 1.5 divided by R2. R2 will be minus 20 by 100. So actually these two expressions will become same. So I will get 1.5 minus n times L into 100 by 20, double of this, and this makes it 15 minus 10 times NL. So this is a linear function of the refractive index of the surrounding medium, straight line with a negative slope, and the answer according to this is option B. So if we use this formula, then the answer is B. But there have been instances in previous papers where power has been taken as 1 by F, and in the routine textbook like NCERT it is written as 1 by F. So if we talk about power as 1 by F, so in that case I'll use Lensmaker's formula straight away. So it will be mu by mu naught minus 1 times 1 over R1 minus 1 over R2, and in that case power becomes the refractive index 1.5 upon NL minus 1 times 100 by 20 into 2. That makes it power as 15 by NL minus 10. In that case, this is some hyperbolic kind of variation, and with that hyperbolic variation you can see when NL is 1 the power is 1.5, and when NL is 1.5 the power becomes 0, and you can check out the options. So we obviously C and D are rejected and we get option A. So if we choose power as 1 by F, we get the answer as option A. If we choose power as NL by F or vergence or the reduced power using the standard power formula of mu2 minus mu1 by R, then we get option B. I'm not sure JEE is going to accept which answer as the correct answer. My idea is most likely it is going to be a double key. Let's see. All right, with this, let's move on to the next question. And this is again one of the most expected topic in which they will ask question, modern physics, Bohr's atomic model. And this time they have framed a very good question just on the basics. So no catch, nothing. You just have to write the equations carefully. You should be good at writing variables, parameters, and solve it. So this is again a test of your patience and how neatly you are able to write the equations and solve. So we have a hydrogen atom, and we are given Vk, Rk, and Kk, denoting the velocity, orbital radius, and kinetic energy of the electron in the kth orbit. Usually we will say nth orbit, but they have given kth orbit. And the electron undergoes a transition from nth orbit. Here n is not a variable, k is a variable. Be careful about it. Nth orbit emitting radiation corresponding to Lyman series. So when it is corresponding to Lyman series, that means it is going to jump back to 1. So electron is undergoing a transition from n. So from k is equal to n to k is equal to 1 is the transition that is happening. So k is the principal quantum number over here. Given h is the Planck's constant, epsilon naught the permittivity of the free space, we are interested in talking about option A, magnitude of change in kinetic energy, magnitude of change in de Broglie wavelength, frequency of the radiation. Okay, let's start with option A. Let's think about change in kinetic energy. So kinetic energy in the kth orbit is, excuse me, so the kinetic energy in the kth orbit is half m vk square. Also, we will have m. Bohr model means you have to use mvr is equal to nh by type pi. M vk rk is n times h by 2 pi. That is the key concept in Bohr's atomic model. You have to use it. Now, kinetic energy is half mvk, and if I look at the option, it wants me to express kinetic energy as a function of h, 4 pi, and all those things. So let's try to convert this. So I need to retain one v and I have to introduce one r. So I manipulate this. I write this as m into Vk into Vk, and this mvk can be written as nh by 2 pi r. So the kinetic energy formula becomes half times nh by 2 pi times rk times vk. That makes it nh, not nh. My bad. I was telling you that it has to be written as k. So it must be k times h by 2 pi. So I will write over here it is k h by 2 pi. So this becomes kinetic energy in the kth orbit as k h vk by 4 pi r k. So I can put k is equal to n and k is equal to 1 to find the change in kinetic energy, and if I put k is equal to n and k is equal to 1, I am going to get option A as the magnitude of change in kinetic energy. Okay, so let's talk about the magnitude of change in de Broglie wavelength, and this wavelength I have to write in terms of kinetic energy. Okay, ठीक है. So let's talk about this. De Broglie wavelength is lambda is equal to h over m vk in the kth orbit, and I have to express this in terms of kinetic energy, purely kinetic energy, and also h into pi. Let's look at the option. E square by 4 epsilon naught times 1 by kn minus 1 by k1. So I have to convert this into E and all those things. Okay, I got the idea. So let's talk about kinetic energy. Kinetic energy के लिए I'll start again. So kinetic energy in the kth orbit is half m vk squared, which can also be written as half m. Now we also know that m vk times rk is equal to k times h by 2 pi, and I can use this. Okay, so kinetic energy, I'll replace Vk with K h by 2 pi m times Rk. So I will get kinetic energy in the kth orbit as K h upon 4, okay, squared, K squared h squared by 8 pi squared m times Rk squared. I'm not interested in this kind of an expression. I need to think more. Okay, let's think of it more. So kinetic energy, I can also think of kinetic energy as, I know that in Bohr's atomic model, the electrostatic potential energy will be minus E square by 4 pi epsilon naught R, and the kinetic energy will be half of this with the positive sign. So E square by 8 pi epsilon naught R, and R I can replace with momentum mv. Yes, that is a better idea. So E square by 8 pi epsilon naught R. R can be replaced using mvr is equal to kh by 2 pi. So R will be replaced by kh by 2 pi m vk, and in fact h by mv is de Broglie wavelength. So it is k times the de Broglie wavelength lambda k divided by 2 pi, and r I will replace with k times lambda by 2 pi. So the kinetic energy in the kth orbit now is, I will get in terms of this. So this is E square by 4 epsilon naught k times lambda k. Yes, this is the useful relationship. So lambda k will come out to be E square by 4 epsilon naught k times the kinetic energy in the kth orbit. This k is principal quantum number. So lambda n will be E square by 4 epsilon naught n times kn, and lambda 1 will be E square by 4 epsilon naught k1, and then I can subtract the two to get the answer. Let's check the options now. So it is E square by 4 epsilon naught 1 by kn minus 1 by k1, and I am getting an extra n over here. So option B is not correct. So option B is not correct. All right. So let's talk about the frequency of the emitted radiation, and this frequency, as you can see, I have to talk in terms of simple energy. So this is comparatively easier. So H times F will be equal to the total energy in the n value minus the total energy in the first value. Electron will lose energy, and total energy is negative of the kinetic energy or half of the potential energy. Potential energy is minus E square by 4 pi epsilon naught r. So this becomes minus E square by 8 pi epsilon naught r. So this is Rn. Yes. So the difference of these two divided by h. The difference of these two divided by h, and that is the option C. So option C is the correct answer. So we get option C as the correct answer. Now let's talk about option D. So in option D, we are interested in calculating magnitude of change in total energy. We just calculated the magnitude of change in total energy. Okay, now he's asking in terms of V and R. So I need to manipulate this again, H by 2 pi. I think from there I can do this. Option A. In option A, we calculated the magnitude of change in kinetic energy. And I think magnitude of change in total energy should also be this, because I know that total energy is nothing but a negative of kinetic energy. So if the kinetic energy is half mv square, the total energy in Bohr's orbit comes out to be minus half mv square. So this should have matched with option A, but we got a 4 pi over here, but we are getting only a 2 pi over here. So this is not correct. So the correct answer is A and C for this question. All right. So we have done 5 questions. JEE will grill you like this. So much of calculations in one paper. Anyways, next question. A particle is thrown with the speed v from a point O at an angle theta. This looks an easy question to me. Projectile motion. I am good at projectile. So it is thrown with speed v at an angle theta, so that it passes through a point P at a height of 1 meter, horizontal distance 5 meter. Acceleration is g meter per second square. Then we have to find the correct statement. So this looks like a question of trajectory to me. So I can write, I can choose the point of projection as 0, 0. So if I choose this as 0, 0, this is 0, 0, then this point has a coordinate 5, 1. So let's apply y is equal to x tan theta minus g x squared by 2u squared cos squared theta. So we'll put y as 1, x is 5 times tan theta minus g times 5 squared 25 upon 2 v squared times cos squared theta. Okay, so I have to check if theta is 45, then v is 5 root g by 2. So put theta is equal to 45. Y is equal to 5 times 1 minus g into 25 by cos square 45, 1 by 2, this will cancel by v square. So 5 minus 1, 4. So 25g by v square is equal to 4. 25g by v square is equal to 4. So v square is equal to 25g by 4. So root of this. So root of 25g by 4. Yes, that is the answer, 5 by 2 root g. So option A is correct. Now, if theta is 45 degree, the particle reaches its maximum height before it reaches P. So, if theta is 45, it is already given that it passes through P, then we know that the speed is this. And now you want to find out whether it reaches its maximum height before it reaches P. So, if it reaches its maximum height before it reaches P, then P must lie somewhere here in the trajectory. And therefore, the range by 2 must be less than 5. So r by 2 must be less than 5. R should be less than 10. I need to check for this. Let's plug in the formula. Remember formula for R? R is V square sine square theta by 2G. V square I calculated 25G by 4. Sine square theta is 1 by 2. Sorry, this is not R. My bad. This is how you lose marks in JEE Advanced. Range is u square sine 2 theta by g, that is 25g by 4 into sine 2 theta becomes 90 by g. So range is 25 by 4, which is something like 6.25. So the range is 6.25, and clearly this range is less than 10. That is what we wanted. Yes. So if theta is 45, the particle reaches its maximum height before it reaches P. Okay. Now if theta is 30 degree, particle reaches its maximum height after reaching P. So I have to find for theta V also. So I'll have to plug in the values of theta and validate whether this is correct or not. So again, y is equal to x tan theta minus g x square by 2u square cos square theta. First I put theta is equal to 30 y1 x5 to find speed. So 1 is equal to 5 times tan 30 is 1 by root 3 minus g times 25 upon 2 into v square into cos square 30, that is 3 by 4. So I get 1 is equal to 5 by root 3 minus. Okay, let's keep this like this. 4 to 50. 50g by 3 v square. So I get 50g by 3 v square is equal to 5 by root 3 minus 1. So that gives you v square by g as 50 by 3 into root 3 upon 5 minus root 3. Okay, some problem. ये स्क्रीन चेंज हो गया, देखो जरा. यहाँ नहीं आ रहा. So let's talk about the question number 6. So this is based on projectile motion. Let me read the question for you. A particle is thrown with the speed v from a point O at an angle theta above horizontal plane such that it passes through a point P at a height 1 meter, horizontal distance of 5 meter. So we are given a point which has been projected from point O, and it is going to move like a parabolic trajectory and pass through point P. So I feel like I need to write equation of trajectory. Anyways, let me read it first. So if the acceleration due to gravity is g meter per second square, I need to find the correct statement. So it is asking that if the angle of projection theta is 45 degree, then the speed is this. Okay. Then if theta is 45 degree, the particle reaches its maximum height before it reaches point P. Then if theta is equal to 30 degree, the particle reaches its maximum height after reaching P. So I have to like validate whether the point P is beyond the maximum height. That means 5 meter is more than r by 2 or less than r by 2. These are the things I need to test for it. And also for theta is equal to tan inverse 1 by 5. So again I have to check multiple things. So let's try with first one. So the equation of the trajectory I will write y equal to x tan theta minus g x squared by 2u squared cos squared theta, and I'll choose the point of projection as 0 0, horizontal as x-axis and vertical as y-axis. The coordinate of point P will become 5 comma 1. So x is 5 and y is 1 in this. So let's put the values. So I'll get 1 is equal to 5 tan theta minus g times 5 squared by 2 times u squared cos squared theta. So I'll check for theta is equal to 45 degree first. So if I put theta is equal to 45, I will get 1 is equal to 5 times 1 minus g into 25 by 2 times u squared or v squared. Cos square 45 will be 1 by 2. So that gives you 1 is equal to 5 minus 25 by 25g by v square. That gives you 25g by v square is equal to 5 minus 1, 4, or v square is equal to 25g by 4. That is v is equal to 5 by 2 root g, which is correct. So option A is correct. And now let's talk about option D also. So option D is if theta is tan inverse 1 by 5. Tan inverse 1 by 5 is an interesting angle here. It is like this angle is tan inverse 1 by 5. So if I throw directly towards that particle point P, it will never cross that point. So D is for sure wrong. So now I have to verify for option B and option C. Now option B says that if theta is 45 degree, particle reaches its maximum height before it reaches P. So if it reaches its maximum height before it reaches P, that means the point P should lie somewhere here in the trajectory, and therefore this r by 2 should be less than 5. So r by 2 should be less than 5. So I have to check whether r is less than 10 or not. And same thing I have to do for theta is equal to 30 degree. But I need to find speed also. Lengthy question. Okay, let's work on it. So for theta is equal to 45 degrees, speed we calculated as 525 by 4 g v square 25 by 4 g. Okay. So now range is v squared sine 2 theta by g, which is 25 by 4 g into sine 2 theta will be 1 because theta is 45. So I get range as 25 by 4, which is 6.25. Clearly this is less than 10. So option B is correct. So for option C, I need to go for theta is equal to 30 degree. First I need to find the speed. So y is x tan theta minus g x squared by 2u squared cos squared theta. Let's plug in the values. So y is 1, x is 5, theta 30 means tan 30 is 1 by root 3 minus g into x squared is 25 upon 2 times v square times cos square 30 is 3 by 4. I get 1 is equal to 5 by root 3 minus 25. Okay, this is not 25, this will become 50. So 50 by 3V square, and in the numerator there is G also. So I get 50G by 3V square is equal to 5 by root 3 minus 1. Is it a positive value? 5 by root 3 is yes greater than 1. So this is 5 minus root 3 by root 3. So I get the value of V square by G as 5 minus root 3 by root 3. No, I have to write the reciprocal. So V square by G will be equal to 50 by 3 into root 3 upon 5 minus root 3. That is 50 upon 5 root 3 minus 3. Okay. I'll plug in this value. Now I have to check for range. Range is V square sine 2 theta by G. So the range will be V square. V square is 50 by 5 root 3 minus 3. This is V square by G times sine 2 theta. Sine 2 theta is sine 60 degree, which is root 3 by 2. Okay, so this is 25 into root 3 upon 5 root 3 minus 3. And we want to find out the condition that particle reaches its maximum height after reaching P. So I need to check if R is greater than 10 or less than 10. So I need to check whether this value is more than 10 or not. If this is more than 10, then answer is C also. Okay, let's estimate this value. 25 into root 3. Let's take root 3 common from here. It will cancel. So 25 upon 5 minus root 3. That's it, na? 25 into root 3 upon 5 root 3 minus 3. I have taken root 3 common, it goes. So 5 minus root 3. So 25 upon root 3 is 1.732. So 5 minus 1.732. This will be 2. Okay, so 5 minus 1.732, 514, 3 point, then it will be 268. So this is 3.268, and clearly this is less than 10. So option C is wrong. So option C is wrong. Great. So that finishes question number 6. Exhaustive. Anyways, let's go to question number 7. Okay, 7 is thermodynamics. A quasi-static cycle of a monatomic ideal gas, degrees of freedom 3. Then we have isothermal process AB. Okay, this is isothermal. This one is isothermal. Then we have an adiabatic process. And then, okay, so the cycle has heat input Q in. So obviously the heat input will be here in the expansion, because here Q is 0, and this must be the point where heat is being rejected. Okay, okay. The question looks like difficult one. Efficiency defined as this: Q in minus Q out, ln 2 values given. Okay, let's read the options first. If V2 by V1 is 8, heat released in process BC is smaller than the heat absorbed in the process AB. To have to compare. In this complete process ABC, the net work done is greater than 0. So the Q net must also be greater than 0, because there is no change in internal energy for the cyclic process. I can see this process. So this is expansion, positive work, 0 work, negative work, positive work is more. So W is greater than 0, hence net Q has to be greater than 0. So Q in minus Q out has to be greater than 0. So Q in will be greater than Q out, and it will be independent of this ratio V2 by V1. It just depends on this clockwise nature. So option A is correct. Okay. Now for a given value of V2 by V1, the efficiency does not depend on the temperature of the isothermal process. For that matter, I need to find the efficiency. Efficiency will be, I need to write Q in, I need to write Q out, and efficiency will be 1 minus Q out by Q in. Now Q1 is the for the thermal isothermal process, which will be nRT. T is the temperature of the isothermal process. Okay, ln of V2 by V1. And Q out will be in the process BC. What kind of a process is BC? Isochoric process. An isochoric process, the heat rejected will be minus NCV delta T. Heat will be NCV delta T. Rejected will be minus NCV delta T. So let's write this heat rejected Q out as minus N is number of moles, let it be N only. Cv is 3R by 2 and delta T will be Tc minus Tb. Okay, Tb though I know which is T, but Tc I don't know. But I can relate Tc with Tb or Ta because I know that AB is an isothermal process, AC is adiabatic. So let's go for the adiabatic process. For the adiabatic process, we will have Tv raised for gamma minus 1 is equal to constant. So temperature at A, which is again the same temperature T, which is B, times V1 power gamma minus 1. Gamma will be, gamma is 1 plus 2 by F. 2 by 3, 5 by 3. So 5 by 3 minus 1 is 2 by 3 is equal to the temperature at C, which is Tc, into the volume V2 power 2 by 3. So Tc can be represented as T1 times V1 by V2 power 2 by 3. So Q out I will be able to calculate. This will be minus 3 by 2 nr into, I will put Tc in terms of T1 and Tb is also T. So this becomes T into 1 minus, not 1 minus. Okay, let's adjust this minus sign. 1 minus V1 by V2 power 2 by 3. And if I fit in the value in efficiency, efficiency is 1 minus Q out by Q in. Now if you see Q out, I have calculated this, and Q in is this. When I divide the two, this nRT term will cancel out. If the nRT term will cancel out, then it becomes independent of the temperature. So B is also correct. Right. And if V2 by V1 is 8, temperature at A is 4 times temperature at C. That is already there, this relationship. Let's validate this. So temperature at A is T1. So Tc is equal to T1 times 1 over 8 power 2 by 3. That is T1 by 4. Yes. So Tc is Ta by 4. So Ta is 4 Tc. So C is also correct. And if V2 by V1 is 8, pressure at A is 4 times pressure at B. A and B, so we can have P1 V1 is equal to P2 V2 na. So pressure ratio must be inverse ratio of the volume. So it should be factor of 8, not 2. So D is not correct. So answer is A, B and C. Good. So let's move on to the next question. Looking at this, I feel like my life is going to become a bit easy now. The electric field associated with an electromagnetic wave traveling in vacuum is given by E naught sine of 3y plus 4z plus omega t I cap, where omega is the angular frequency. We have to check the correct statement. Wave is traveling in this direction, so I will need to find the direction. I need to find the wave vector, omega, and the magnetic field. All right. So the electric field is given as sine of 3y plus 4z plus omega t I cap. Okay. Yes. So electric field is in I cap direction. And wave is traveling in. For that matter, we should think of the equation as E vector is equal to E vector is equal to E naught sine of omega t plus or minus k dot r. Then k gives the direction. So you think of this term, you can write this as 3j cap plus 4k cap dot r, that is xi cap plus yj cap plus zk cap. So this k dot r, this becomes 3y plus 4z. So clearly the k vector, the propagation vector is 3j cap plus 4k cap. And the standard equation is minus k dot r. So if it is minus k dot r, then the wave is going in the k cap direction. So k dot r over here is negative of this, so k should be negative of this. So the propagation vector is minus 3j cap plus 4k cap. So the direction is minus 3j cap plus 4k cap divided by 5, the magnitude of this vector. So option A is correct. Now the magnitude of the wave vector, clearly magnitude of the wave vector is 5, which is not matching, so this is not correct. Magnitude of omega. So this speed, okay, wave is traveling in vacuum and c is given to me, so omega by k is the speed of light. So omega is c times k. So 3 into 10 raised to power 8 into k is 5, that is 1.5 times 10 to the power 9. So c is also correct. Now the magnetic field. Magnetic field I have to verify. Magnetic field is E naught by C sine of 3y plus 4z plus omega t times 4j minus 3k. So I have to check the direction of the magnetic field vector. And the magnetic field vector should be traveling. Okay, first of all, one important thing which I can notice is the amplitude of magnetic field should be equal to amplitude of electric field divided by C. That I know, C is E by B. So B naught must be equal to E naught by C. So first of all, except this term, the rest of the term should have B naught, which is not here. So this must be wrong. And if they had divided by 5, then I needed to check further. But right now, this itself is not matching. So option D is not correct. So answer is A and C. Good. Okay, let's go on to the next question. Okay, we have a tank that contains two immiscible liquids, density 6 rho and 2 rho. The higher density liquid is filled up to height L by 2, higher density. So this one is 6 rho and this one is rho, no, 2 rho. And the thin rod has a density rho and length L. It is fully immersed and hinged at the bottom so that it can oscillate freely. Now it is slightly disturbed. I need to find the time period. So when it is slightly disturbed, so the initial position of the bar was like this, and now it has been slightly disturbed. So although I'm drawing a large angle, but we will assume that this angle is very small, so that the amount of the bar in liquid 1 and 2 does not change. So they will remain approximately L by 2, and the bind force will not change. So let's first find the bind force. Okay, so the bar will have a mass m that will be equal to cross-sectional area into L into G, that is mg value, rho ALG, right? Yes. If I talk about a bind force on the lower portion, it must be 6 rho into A into L into G, not L, it is L by 2. So this becomes 3 mg, and the bind force on the upper portion becomes 2 rho into A into L by 2 into G, that is mg. Now this body is experiencing a force mg at its center of mass, which is the gravitational force. It is experiencing a force like this, which is 3 mg and it is experiencing a force like this, which is mg. This is 3L by 4. No, this is L by 4. Why I'm saying 3L by 4? So this is 3L by 4. So 3L by 4 into theta. That will be this perpendicular distance. This is L by 2 into theta. This is 3L by 4 into theta. Right. So the torque would be, I have turned it clockwise. So mg, the gravity torque will be mg into L by 2 theta minus, due to this mg, it will be mg into 3L by 4 times theta, and due to this 3 mg, it will be minus 3 mg into L by 4 times theta. So the torque becomes 3L by 4, 3L by 4, 3L by 2, 3L by 2 minus L by 2L minus mgl theta. So the torque becomes minus mgl theta. This is of the form torque is equal to minus c theta. Time period will be 2 pi under root I by c. Do you remember the moment of inertia about hinge? Moment of inertia will be ml squared by 3. Did I press something bad? ml square by 3 and c is mgl. So the time period is 2 pi square root L by 3g. Yes, the time period comes out to be 2 pi square root L by 3g. So n is root 3. So n is root 3, that is 1.732. So we have to report up to 2 places after decimal. So we'll report the answer as 1.73. Good. Let's move on to the next question. Okay, here is another question from thermodynamics as shown in the figure. 5 Carnot engines, each with efficiency eta and same number of cycles per unit time, are operating between 6 heat reservoirs. The amount of heat released per cycle by one engine is completely absorbed by the next engine. Okay, so this Q1 goes to the other one. Okay. And W is the amount of total work done by all the engines. So I am getting W1 plus W2 plus W3, total work done W5, which is given as W. Okay, and we want to find the efficiency. So efficiency should be my total work output upon heat input. Heat input is Q naught. Q5 is lost. I think there is some information missing. I also have the question paper with me. Let me read it from there. Okay. Yes, one line is missing. It is written net efficiency of the system is found to be 211 by 243. This is given to be 211 by 243. We have to find eta. What is eta? As shown in the figure, 5 Carnot cycle, each with efficiency eta. Okay, so net efficiency is given to be 200 by 243 and I have to find the efficiency of each individual one. All right, so let's say eta is the efficiency. So if Q naught is the heat absorbed, then eta times Q naught is the work output, and therefore heat rejected will be Q naught minus eta times Q naught, that is 1 minus eta times Q naught. So the heat rejected will be 1 minus eta times Q naught. This is Q1. And then Q2 will be Q1 times 1 minus eta, and therefore it will be 1 minus eta square times q naught. Similarly, I can find q3, then q4 and q5. So q5 finally will be 1 minus eta whole power 5 times q naught. Right, now efficiency. Efficiency is W upon Q naught. W will be Q naught minus Q5 upon Q naught. This efficiency is given to be 211 by 243, and this is equal to 1 minus eta power 5. Great. So I get 1 minus eta power 5 is equal to 1 minus 211 by 243. Take the LCM. 243 minus 1132. That looks a nice number because I have fifth power over here. So I get 1 minus eta as this is 2 raised to power 5 and this is 3 raised to power 5. So this is 2 by 3. So eta comes out to be 1 by 3, that is 0.33. So the answer to this question is 0.33. Okay, let's move on to the next question now. So as shown in the figure, we have an insulated container. Insulated container, no heat exchange, is fitted with a thermally conducting but immovable partition P1 and a freely movable but thermally insulated piston. So the only way of the only thing conducting is P1, P2 is insulated, container is insulated. So by P1, S1 and S2 are going to exchange heat in between them. P1 is fixed. The partition P1 with thermal conductivity K, cross-sectional area A and width X is fixed. It divides the container into two sections, S1 and S2, each containing 1 mole of a monoatomic gas. So monatomic gas is there, and the piston P2 is moving freely such that the gas in S2 is always at atmospheric pressure. So for this the process is constant pressure, this is constant volume. Initially, the difference between the temperature of S1 and S2 is delta T naught. The time it takes for the temperature difference to become delta T naught by 2. So there is a temperature difference, and because of the temperature difference, heat will flow. As heat will flow, temperatures will change. So initial temperature difference is delta T naught. At any later instant, if the temperature is a T1 for the left chamber and T2 for the right chamber, then T1 minus T2 is the instantaneous value of delta T. Now heat will travel from S1 to S2 and this will cause a change in temperature. So as S1 loses heat, I can write K, the thermal conductivity, into area into T1 minus T2 by X as the rate of heat flow, dq by dt, and this will be equal to minus 3 by 2 nRd of T1 because it is isochoric process, so dq can be written as ncv dt. It is losing heat, that's why negative sign. And also this will be equal to 5 by 2 because S2 is absorbing heat at constant pressure, nR d of T2. So I need to get a differential equation in terms of delta T, that is T1 minus T2. So I get Ka delta T by X is equal to minus 3 by 2 nR d of T1. So I write Ka times delta T by X into 2 by 3 nR with a negative sign is equal to d of T1. And also I can write 2 by 5 nR times Ka delta T by X. X, na? Yes, it is X. Is equal to d of T2. Now this is delta T, so d of delta T is d of T1 minus d of T2. Let's plug in the value. So d of delta T will be equal to d of T1 is minus 2 by 3 nR Ka delta t by x minus d of t to minus 2 by 5 nr into Ka into delta t by x. Okay, so I get d of delta t by delta t, and there must be time also, na? This is by t1 by dt, so this is by dt by dt, so this is d by dt of this, d by dt of this is d by dt of this. Now dt I'll take onto the right side, so I'll take the LCM. I can take something common, 2 by 3 plus 2 by 5, तो 5 3 5 plus 3 8 by 15 16 by 15 Ka by Nr times dt. Let me verify the calculation. 2 by 3 plus 2 by 5, 16 by 15 with a negative sign. So this differential equation is there, which we need to integrate, and we want to find the time it takes for temperature to become delta T by 2. So the time in which temperature will become delta T by 2 is ln 2 times factor should come. Anyways, we'll integrate it. So I got d of delta T by delta T as minus 16 by 15 Ka by Nr times dt. Let me check whether it is correct or not. ठीक है, correct. So integrating both sides, initial value delta T naught, final value delta T naught by 2. So I'll get ln of delta T with the limits delta T naught to delta T naught by 2 is equal to minus 16 Ka by 15 Nr into the time. This is minus ln 2 is equal to minus 16 Ka by 15 Nr times T. So T will be equal to 16 Ka by 15 Nr ln 2. Let's plug in the values. Okay, Nxr by Ka. Time is N times Xr by Ka. Okay, I have written 15 Nr ln 2 by 16 Ka and have to compare it with Nxr by Ka. Okay, number of moles. What about the number of moles? That N is 1. So let me put that N as 1. And then I have to compare this with Nxr by Ka. Nxr by Ka. I am missing one X also. Delta T by X. So Ka by X. X was there always. X. So this now R goes on both sides. This. So the value of N is N is 15 ln 2 by 16, and ln 2 is given to me in the question. It is 0.7. So 15 into 0.7 by 16. 15 into 0.7 by 16 is the answer. Let's solve it further. So ये क्या 15 into 7, 105 by 160. Let's solve it. So 16. This will be 16 into 5, 16 into 6, 96. Then I'll be left with I'm not able to solve it. 105 by 160. So 16 से डिवाइड करते हैं. 16. Now I'm left with a 9. So 9 means 16 fives are 80. Then I'll be left with 10, again 6. So this is 0.656 I will get approximately. So there must be some range. I can mark it as 0.66 as the answer. So answer is 0.66. So that gives me the answer for this question. Okay. एसी बंद हो गया, गर्मी लग रही है. Okay, let's start with the next question. So let's start with question number 12. A hollow right circular cone of base radius r and height h with its tip at the origin is rotating about the z-axis with angular velocity omega as shown in the figure. The cone carries a total charge q uniformly distributed on the curved surface. We want to find the magnitude of magnetic field at 0, 0, z, where z is greater than r and greater than h. And we want to find n. We want to express this in terms of mu naught by 4 pi q r square omega by z cube. So this is a spinning charge distribution. It is going to behave like a current loop or a magnetic dipole, and we are interested in calculating the field at a large distance from it. So if I want to find the field at a large distance, I can treat it as a dipole and on the z-axis. So z-axis is the axis of this. So field at a large distance should be mu naught by 4 pi times 2 m by z cube. And I want this to be n mu naught by 4 pi times q r square omega by z cube. So n is 2 times the magnetic dipole moment upon q r square omega. So this is what we want to find out. So this question is not about calculating magnetic field, it is about calculating the magnetic dipole moment. For a uniform distribution of charge, the magnetic dipole moment can be easily related to angular momentum as q by 2m, and angular momentum can be written as I omega, and for this cone, I about this axis is as good as the moment of inertia of a disk. So if this is r, then I may be written as mass m into r square by 2. So I'll plug in the value. M by L is equal to q by 2m. So m will be q by 2 times L. L is I omega. I is m r square by 2 times omega. So the magnetic dipole moment is q omega r square by 4. If I put m as q omega r square by 4, so I'll be left with 1 by 4. So n is 1 by 2, that is 0.5. So the answer to this question is 0.5. Finally, I got a question which I could solve fast. So the value of n is 0.5. That's great. Okay, let's go on to the next question. This question is again going to bring challenges for us because this question is having a lot of tricky data and calculation. Anyways, we'll solve it. List 1 shows 4 configurations made of straight and semicircular narrow tubes containing air. A sound wave of wavelength lambda is equal to 0.29 meter enters these structures at point S, and a sound detector is placed at D. So this is about interference. One of the wave goes from path 1, other one goes from path 2, and we have to find the path difference, and that path difference we are going to equate it to lambda. A sound wave of wavelength lambda is equal to 0.29 enters this, and list 2 contains possible smallest value of L. for which the detector records maximum amplitude. So path difference should be equal to n lambda. We will see whether I have to take n as 1 or not. Okay, so case 1. In case 1, path difference. One of the wave travels pi r. Pi times r. R is L by 2. And the other wave travels L. And this must be equal to n lambda. So pi times L by 2 minus L is equal to n lambda. That gives you L is equal to n times lambda upon pi by 2 minus 1. I want minimum, so take n as 1. So this is 0.29 divided by pi by 2 minus 1. Pi by 2 minus 1, 3.14 minus 1, 2.14. I have to solve it. So let's do it this way. So it is lambda is 0.29 and pi I will take 22 by 7. So this is 11 by 7 minus 1. This is 0.29. 11 minus 7 is 4 into 7. And this will make it somewhere around 0.7, 0.7, slightly more than 0.7. So this will be slightly more than 0.49. So the best possible match over here is 0.51 meter. So P matches with 3. Okay, let's go to the second case. This looks easier. One of the path is L and the other one is 0.5 L vertical, another 0.5 L vertical. That makes it L and L 2L. So 2L minus L is the path difference and this must be equal to n times lambda, which is 0.29. So L is 0.29. So this makes it fourth option. Q goes with 4. Then let's go for the third case. In third case, the path difference is, okay, this L and this L will balance. So the only path difference is that semicircle. Is it a semicircle? Yes, it looks like a semicircle of radius L root 2. So L root 2 is the radius, no, diameter. So L root 2 by 2 is the radius and pi times of this must be equal to 0.29. So I'll get L as 0.29 into root 2 by pi 3.14. Let us estimate it to the nearest one. Root 2 is 1.414. So let's write it as 1.5 for time being. 1.5, 4.2.3, 0.45, somewhere around 0.15. So 0.13. So this must match with option number S, 5. So R goes with 5. The question is not complete here. Let me see the options which I have printed over here for this question. Yes. So the option is P3, Q4, P3, Q4, R5. That message with option D. So option D is the correct answer. We can solve for the other case also. That is not a problem. But I'm getting option D as the answer. I can easily check for option S also. So in option this angle is 45 degree and 105 degree. This total length is L. So you will need to find those lengths. But I think this question is not about going for those calculations. We can go for option D. So option D is the answer. Let's move on to the next question. Question number 14. Finally, a question which I can mark directly without any calculation. Some breather. Okay, in the list, 4 optical effects are mentioned. The physical phenomena of light which are essential to describe these optical effects are given in list 2. Choose the option which describe the correct match. Colorful sky in North Polar region, Aurora Borealis. Aurora Borealis comes because of the charged particles of solar wind that enters into Earth atmosphere. They reach the poles and they ionize the atoms over there, and because of that some colored radiations are emitted. So it must match with option 5. Some of you may not know this much of detail. I believe for solving this question this was not needed, you could eliminate. Q option, partially polarized sunlight comes out of scattering, so Q goes with 4. Rainbow is a dispersion and reflection, it goes with 1. Dark and bright bands are found in diffraction, so it goes with 3. So 413. So QRS 413. QRS 413. QRS 413. So only one of the option is there, option A. So answer is option A, and it shows P as 5 also. So that's great. All right, next question. Okay, this is also a favorite question of JEE Advanced. They will keep on asking questions like this. The graph showing the variation of induced EMF. In previous year also they have asked a very nice question on this. This is a lot easier than that. We have to think about different loops which are entering into the region of magnetic field and talk about the variation of induced EMF in it. Let's deal them one by one. This is easy actually. If you look at the P option, we have a semicircular loop that enters into the field. So this semicircular loop, as it enters into the field, the flux starts increasing and it is turning about O. So it will go like this, and then it will become like this, and then it will start coming out. So first it will completely enter and then it will completely move out. So first flux will increase and then the flux will decrease. There will be no state in which some constant flux will be there, so it must match with option 3. So P must match with option 3. I'll keep the options also ready, they are not printed here. Okay, this is a question here and I have the options also. I will match it up. So P goes with 3. Then let's talk about Q. So Q, this angle is 60 degree and this must be 60 again, 60 again. So when it turns by 60 degree, flux increases. After that, for next 60 degree, there is no change in flux. And then for another 60 degree, the flux will again increase, and then this would have entered completely into the magnetic field. So increasing, then constant, then increasing means the sign will remain same, but it will be having a break. So clearly graph 2 shows this, that we have a certain current, then current is 0, then again same sense of current, then the current reverses direction. So 3 and 2. 3 and 2, there are two options like this, so I need to solve further also. Okay, we'll solve it. So R is just a loop of 60 degree. So for 60 degree, it will have increasing flux. For another 120 degree, there will be zero flux, and then there will be decreasing flux. So increasing flux, then for 120 degree, there will be decreasing flux. So which one is that? And I think that is option 1. So 3, 2, 1, that gives me the answer. S must be 4 because of the options that I have in front of me, but still we can verify it. In the option S, you can see that right now when it is moving, there is no change in flux. So it is like this. So as it goes like this, and it goes like this, there is no change in flux. Then this portion starts coming out, this portion starts going in. So the decrease in flux is compensated by an equal amount of increase in flux. So there is no change in flux. So it must match with option 4. That was not that tough. Matrix match, we could solve for 3 options and find the answer. Okay, that brings us to the last question of this paper. The paper is lengthy and exhaustive, As I've seen the feedback from the students, many of the students were not able to manage time, but those who were good at physics, they are actually getting high scores because they could save time in physics and they could devote it to other subjects also. So the final question, list one shows four planar structures made of uniform solid rods, each of mass m and length L. Okay, all the four cases have rods having lengths L and mass m. Fine. And we are giving some tilted axis and we want to find. So the most important point over here is, if I have a bar like this and I want to find the moment of inertia about an axis like this, such that bar makes an angle theta, bar mass is m, length is L, then bar's length projected perpendicular to it will be L sine theta, and moment of inertia about this axis will be ml square sine square theta by 3. This is the key formula, and in all parts you have to use this. Apart from that, also there is some interesting thing that I would like to tell you here. Let's talk about question number option P. In option P, I am interested in calculating the moment of inertia about this inclined axis. And if you see that this is 45, this is 45, so if I write m into L sine 45 squared by 3 and double of this, answer will be simply ml square by 3. So this was one of the easiest part, ml square by 3, so it matches with option 5. Okay, let's solve for some other easy part. S option. If we solve for S option, it must be twice of m into L sine 30 squared by 3. So that makes it 2 into m into L square by 4 into 3. So ml square by 6. So this matches with 2. Does that help? P5S2, P5S2, P5 S2. Array, I'm looking. Here are the options. Sorry. P5 and S2. P5, S2 is there in option A and option B. Okay. So Q and R I need to check. R is also same in both of them. So let's go for solve for Q now. So Q will help me find the answer. So if I talk about Q, then it will be about this axis. So for one of the bars, it is m into L sine 60 whole squared by 3, double of this for two bars. And for this bar, it is all the particles at the same distance, and that same distance is L sine 60, L root 3 by 2. So for this, it is m into L sine 60 squared. So the final answer must be ml square sine 60 is root 3 by 2. So 3 squared 9 by 4, 9 by 2, 9 by 6 plus m into L square into 3 by 4. And this is 3 3s are 9, 3 2s are 6. So 6 by 4, 9 by 4. Is there an option like this, or I did some calculation mistake? I'll have to check it carefully. Let me solve for option Q carefully. So this is like this. So for this one, it is 60 degree. So m into L sine 60 whole squared by 3, double of this. And for this bar, it is this perpendicular distance, which is again L sine 60. So this is m into L sine 60 squared. So 2 by 3, so 5 by 3 times m into L sine 60 squared. So 5 by 3 into m into 3 by 4. So 5 by 4 ml square must be the answer. 5 by 4 ml square. Do we have any option like 5 by 4 ml square? Yes, it is 1. So 1 for this. So 5, 1, 2. 5, 1 and S2. Option A is the correct answer. P5, Q1 and S2. Great. So that brings us to the end of this question paper. The paper was amazingly framed within the domain of JEE syllabus. Some very good questions were framed, and those who have not been practicing, like solving lengthy questions or making calculations or not dealing with the proper numbers, they are bound to lose in this kind of a paper. Whereas a student who has done rigorous practice of solving the questions rigorously to the end and finding the answers, doing proper arithmetic, they definitely will have an edge in this question. All right, thank you very much. Goodbye.